Welcome back, young kiddies, to our third video lesson for Chapter 3. Today we're going to focus on solving multi-step equations. Alright, so to solve multi-step equations, we're going to combine a lot of things we've done in last chapter and what we've done up to this point. Multiple steps, again, we're going to talk about, we've done one step, we've done two-step, multiple steps are going to be anything that are going to require 3 or more steps. So it's going to combine some things we've talked about, such as combining like terms. So you're going to have to recall what that means. Using reciprocals. Again, what the heck does that mean? The distributive property. And then what we've been working on this whole entire chapter is using inverse operations. Remember, our goal is, given an equation, to get the variable by itself, to isolate the variable by using some of these properties. All right, so let's take a look at the first example. So this one is going to be one in which, before we actually do some of the stuff we did in sections 1 and 2, we're going to have to apply some ideas from last chapter. So we have negative 2 plus 3x equals 10. So notice how I have two variables on the same side. Oh, so if I'm trying to isolate one of them, well, which one do I isolate? Well, notice that they're both x, right? I both have the same variable of x. So what I can do first in this one is combine like terms. So I can apply that idea that we used last chapter. So I see that 3x plus 3x, combining those is going to give me 6x. Everything else in the equation stays the same. And now what I have is just x by itself. Well, I mean, there's other things with it, but only one x. I don't have any other terms here that have x in it. So now what I'm going to do is simplify and solve for x. So what we have here is this two-step equation. So remember from last section we had the idea of GEMDAs, right? The order of operation. When we solve for equations doing multi-step or two-step problems, what we're going to do is doing the opposite of the order. So the opposite, we're going to start with adding and subtracting first. So what I see here is I have 6x plus negative 2. So what I'm going to do is I'm going to, well, here I have negative 2 plus. You can think subtraction, but what I'm going to do is get the inverse. So if it's negative 2, the inverse of negative 2, the opposite would be positive 2. So what that's going to end result is going to be that I'm adding 2 to both sides. Okay? That's going to cancel on this one. That's going to leave me with 6x equals 10 plus 2 is 12. Then the last step, I'm taking 6 times x, so to undo that, I'm going to divide by 6 on both sides of the equations. 12 by 6 is 2, and there is my answer. And again, what you can do, and I'll show it in this one, but I won't show it on the other examples in this lesson, is you can take x equals 2, and remember you can check to see if it's a solution. So if I ask you to check, right, which is not required, but it's something you can do, what we're going to do is take 2 and plug it back in the equation. So I got negative 2 plus 3 times 2 plus 3 times 2 equals 10. That's going to give me negative 2 plus 6, right? Multiply first. Multiply this one first. Plus 6 equals 10. And now I have a whole series of subtraction and addition. So first one I have negative 2 plus 6. Well, negative 2 plus 6 is 4 because the 2 is negative. Plus 6. 4 plus 6 is 10. Does it equal 10? Check, please. You bet it does. So that means my solution, of 2 is a correct solution. All right, next example, we are going to use the distributive property to solve an equation. So notice here I have negative 2 times x minus 4 minus 5 equals 3. So notice how my variable x is trapped inside the parentheses. Okay, so one thing I can do here to simplify is use the distributive property. When you see a number times stuff in parentheses, you can automatically know or use the distributive property to simplify. So I'm going to take and distribute the negative 2, not just 2, to the x and the negative 4. That's going to give me negative 2 times x. Negative 2 times negative 4 would give me positive 8. Then minus 5 equals 3. Okay, this is going to combine stuff from last example. I have positive 8. Can't talk. Positive 8 minus 5. I can combine these like terms, right? So negative 2x plus 3 is going to equal 3. So notice how combining some of the things we did last chapter, of distributing and combining like terms helps us to simplify this equation, makes it easier for us to solve. Now we can go ahead and try and use the inverse operations now to solve. So we distributed, we combined like terms, now we're going to use our inverse operations. So I have negative 2x plus 3. So what's being done to x is I'm adding 3 and I'm multiplying by negative 2. Which one do I do first? And we're going to go opposite the order of operations, so I'm actually going to do the 3 first, and to do the inverse operation, I'm going to subtract 3. If I do it to one side, got to do it to the other side. That's going to cancel that out, leaving me with negative 2x equals 3 minus 3 is, wait, 0. Uh-oh, don't freak out here. Negative 2x equals 0. That's okay. Remember that 0 is a real number. Perfectly fine. Let's just solve the last step. I have negative 2 times x. So how do I undo that? What's the inverse operation? Multiplication. That's division. So I'm going to divide by negative 2, and I'm going to divide 0 by negative 2. Now, a lot of you are going to want to leave this as 0 over negative 2. But what is 0 divided by anything? Or 0 times anything? It's 0. So this tells me that my answer is going to be 0. Again, I can go ahead and check that, but if you guys want to go ahead and check that, you can. Again, I'm not going to require it of you. I'm not going to do it in this example. All right, next example we're going to use is this idea of a reciprocal. Again, this is something we talked about last chapter. If I take, for example, a fraction of 2 over 3, what is the reciprocal? What does the reciprocal mean? Well, remember, I use the term the flippity-floppity of the fraction. Basically, what you do is you take the fraction and flip it. The numerator becomes the denominator becomes the numerator. The reciprocal of 2 over 3 would be 3 halves. Recall, when did we use this? We used this when we were dividing fractions. Okay? So keep that in mind here. So this example, I have 18 equals 1 half, parentheses, so times negative 3 plus 3h. Okay? And these are in parentheses. So you can look at this and think about the last examples. What could I do? I could certainly distribute the 1 half to the negative 3 and to the 3h. Okay, but I'm not going to do that. I don't always have to distribute. What does this say? It says 1 half times negative 3 plus 3h in the parentheses. So if I wanted to undo the 1 half, I can simply divide by 1 half. Okay? Now, I'm going to erase this, so don't freak out if you wrote this down. That's okay. When I divide by a fraction, what do I have to end up doing on the other side? Well, if I divide 18 by 1 half, I'm going to have to take 18 and multiply it by the reciprocal of 1 half, which is 2 over 1. So what I can do from the start, let me just erase all this jazz. I know you guys are going to be all like, oh, I wrote it down. But each time you see that you are multiplying a variable by a fraction, in this case here, what you can do right away to undo the fraction is multiply by its reciprocal. So to get rid of 1 half, I can multiply by 2 over 1. Okay? I'm going to put the dashed line through here. I'm going to multiply by 2 over 1. If you think about simplifying, what that's going to do is think about cross simplification. The 2 on top is going to simplify with the 2 on bottom, and you're left with 1 over 1 times 1 over 1. Well, 1 over 1 times 1 over 1 is 1 times 1, which is 1. Whoa! All right? So that cancels out. And then over here, I'm going to take 18 times 2 over 1. What is 18 times 2? That's going to give you 36 equals, well, notice here I got rid of this fraction. 1 half is no longer there. So what I have is negative 3 plus 3h. Notice how I dropped the parentheses as well? I can do that because I'm no longer multiplying by anything, because the thing canceled out. If I multiply, you may think, well, yeah, there's still a 1 there, but when I distribute a 1, it's not going to change anything. So it's parentheses drop out, and you're left with that. And now I can simply use inverse operations. So I see the negative 3h plus, or say negative 3 plus 3h. I'm going to work with the addition first. I'm going to work with this negative 3. To undo this negative 3, I have to add 3 to both sides. That's going to give me 39 equals 3 times h. To undo multiplication, I'm going to divide by 3 on both sides. And that's going to give me h is equal to 39 divided by 3, is a solid 13. And remember, same thing to say h equals 13 if you like to write it from left to right like I do myself. Okay? So this one, using the reciprocal. So in all these examples so far, we've talked about distributive property, combining like terms, the reciprocal. We can use all these tricks and trades we talked about last chapter and this chapter to solve for equations. All right, this last example I want to show you guys, just notice it's the same example on both sides. But when you see a problem like this, right, we just went through some examples where you see these and you see the parentheses, you might want to distribute right away. But just to let you guys know, there is not one set way on how to solve an equation. So in this problem, I'm going to show you two methods you can do to solve this one. Sometimes there might be two methods. Sometimes there might be more than two. You never know. Okay, so let's take the one on the left first. What we did in previous examples is we took and distributed first. So we noticed negative 6 times x minus 4. This should be, again, a sign that you need to distribute that. Okay, remember that when we distribute the negative 6, I got to make sure I pay attention to that negative. That's going to give me negative 5. Minus 6 times x is 6x. Minus 6 times negative 4 is plus 24 is going to equal 31. Then what I can do is take one of the examples we did. I see negative 5 and 24. What are those? Those are like terms. So I can take and combine those. Negative 5 plus 24 is going to give me 19. Minus 6x equals 31. Now what I have to use is simply inverse operation. So combine like terms, use the distributive property. Now I can use inverse operations. So I have 19 minus 6x. Careful here. Even though it says subtraction, this 19 is positive. So I would subtract 19 from this side to the other side. That's going to give me negative 6x equals 12. Okay, so negative 6x equals 12. Now I have negative 6 times x. So I'm going to divide by negative 6. Make sure we get a positive x left behind. 12 divided by negative 6, I'm going to get x equals negative 2. Okay, so that's one way to solve the problem. Distributed first, combined like terms, then did my inverse operations. Does that mean you have to save inverse operations last? No, that does not. And that's what I'm going to show you the second method. I can start by doing inverse operations first. So notice how this says negative 5 minus 6 times x minus 4. Now, what I can do is start with this negative 5. I'm taking negative 5 and subtracting this entire term right here. So what I can do is add 5 first. I can start by doing my inverse operations. Why can't I get rid of that 5 first? Some of you might be freaking out right now and say, whoa, what is he doing? Well, it's no big deal. I can do the inverse operation first. Negative 5 plus 5, that's going to cancel out. It's going to leave me with, careful here though, negative 6 times x minus 4 equals 31 plus 5 is 36. Now you might look at this and say, hey, big dog, I want to distribute, but I'm going to pause you for a second. Do you have to distribute? No, technically this says negative 6 times x minus 4. So the x is inside here, but if I want to get rid of this negative 6, I can divide, do an inverse operation first. Whoa, mind-blowing stuff here, mind-blowing stuff. But I can divide by negative 6 to get that to cancel. And then I can divide 36 divided by negative 6. What's left on the left side is I have now canceled this out. I'm left with parentheses x minus 4. But since this term went away, there's no reason for me to leave the parentheses, so I'm left with x minus 4. 36 divided by negative 6 is negative 6. Okay? And then lastly, I can add 4 to both sides, do my inverse operations, and I get x equals negative 6 plus 4 would be negative 2. And notice, both answers work. So what did I do on the left side? The left side I used distributive property, combine like terms, inverse operation. The right side, all I did was inverse operations. I didn't distribute, I didn't combine any like terms or anything like that. All I did was take inverse operations. So you decide what you want to do. You know, life is in your hands, you make the decision. Isn't that a beautiful thing? Because math, folks, math is real life. And I'm going to leave you with that one. Good luck on your mastery check and good luck on your practice problems, kiddies. We'll see you in class. Peace out.